Alright, ladies and gentlemen, these are the video notes for 5.5 CW 7, 8, and 9 and homework 7, 8, and 9 to help assist you guys a little bit on how to complete these type of problems. Now in this unit, in this section of the unit, we're really focusing on the mid theorem here, the midpoint theorem or the mid-segment theorem. And we're going to apply this to certain types of problems. So this is the problem that we're going to focus on right now. In the figure, XY and XZ are mid-segments of triangle RST. Find each measure. So they're saying here that XZ is the mid-segment of the side that goes with RT. XY is the mid-segment of ST. And YZ is the mid-segment of RS. So let's do a little bit of highlighting here, make life a little bit easier. So I'm highlighting here in blue. XZ. This blue line is the mid-segment of RT. They're in relationship to one another. And RT has a length of 28. Our goal is that we need to find XZ. Well, to find out that length, all we got to do is take half of RT. Because XZ is half of RT. That's by definition of our mid-segment theorem that we've been talking about in class. So half of 28, that'll get us 14. So I'll put a little 14 right there on our picture, which is the answer. So that first part, XZ is 14. Now ST, what we're trying to find that entire length over here on the right side. So I'm going to get rid of these blue guys. I'm going to make this 14 a little bit smaller too. Just so we keep it in our back of our minds here. That's 14. We got to find this side ST. So I'm going to highlight that so we know what side we're trying to find. I'll highlight it in red. ST is this length right here that we're trying to find. So we're trying to find that red side, ST. Now, to find that side, we need to know if we have a mid-segment that matches up with it. Now, fortunately, we do. XY, right here highlighted in black, is 27. This is the mid-segment of this side ST. So 27 times 2 will get us the bigger one. So 27 times 2 will get you 54. So the length from all the way from S to T is 54. I'll write that in right there for you. 54. We'll delete that. And the red guy we know is 54. We're going to delete that out too to move on to our next little section of the problem. We got to now find angle RYX. RYX. Our goal is to find this angle right here. RYX. To do this, we know about the mid-segment theorems, but we also know about parallel lines cut by a transversal. We know about vertical angles and alternate interior angles and all sorts of things like that. We also need to know with the mid-segment theorem, we need to know that RT is parallel to XZ. So let's highlight those lines once again. So we got XT. Oh, let's make them blue. So XZ is blue. And RT, we'll make that also blue. So these lines are supposed to be parallel. Even though they don't really look it, they are parallel. And we gotta still find that red angle right there. Well, we have parallel lines cut by a transversal. We talked about that topic quite a bit. And it's now going to be combined in here too. This line is a transversal line in green. This angle and this angle They're alternate interior angles. So that little red angle that we're trying to find, it's the same as 137 by definition of alternate interior angles. So angle RYX is 137. So we're going to type that in, 137. And we'll put it into that little spot for red. I'm going to delete all this extra information because we got to use the same picture to find all the other information. So I'll put the 137 right there. Okay, I'll make this 137 a little smaller, so it's not so crowded. So we have those pieces of information. Now we got to find angle XSZ. So XSZ, let's find that. XSZ, XSZ. We got to find this angle up here. XSZ. Now how are we going to do this? Well, we know a couple things here. We know that's 137. We know this is negative 10. Interesting, because you should only have positive numbers for angles. Well, we'll work with it. We don't know what this angle is down here yet. We know this side length is 27. We know this angle here is 137. So we're going to actually have to do quite a few bit of work here, a little above and beyond thinking to find out what this angle is up there. Well, one thing we know is that there's 180 degrees inside of a triangle. So 180 degrees minus 137 minus a negative 10 will get us this angle down here. So we put that into the calculator. 137, I'm sorry, 180 minus 137. Then minus a negative 10 will get us plus 10. So this bottom left-hand corner, this angle here is 53. Put that in there. We know that by definition of a triangle. This is above and beyond type of problems here, so don't worry if you're struggling a little bit with this. So you know that little angle is 53, because 53 plus 137 minus 10 gets you a total of 180 degrees. Now, we also know one side of a line is 180 degrees. So 180 minus 137 minus 53, that's going to get us a negative 10. So we're going to put that little negative 10 in for that little corner. Make it a little bit smaller. Oh. All right, make it nice and pretty. Negative 10 goes there. We also know by alternate interior angles that that's also negative 10. Now, what else can we do here? Well, we do know some other parallel lines cut by a transversal. Let's highlight some of those. We know that Rx, or Yx, is parallel to ST. And we could use a couple things for transversals. However, which one do I want to use? I think I'm going to use this YZ as a transversal. So I'll make it a different color. We'll do them blue. YZ is my transversal line. So parallel lines cut by a transversal. This angle here of 53, by definition of corresponding angles, we also know that this angle out here is also 53 degrees. The angle that we just kind of made up there because we extended our lines. Now, this blue line is parallel to this blue line. parallel to this blue line. Right there. So if we extend those, so we extended the XS, we know 53 and the angle that we're trying to find, they're alternate interior angles. So that means this 53 and this 53, those angles are the same by alternate interior angles. So our answer for XSZ is 53 degrees. Now angle XYT, well, we found out this angle is 53. We have found out by alternate interior angles here that's negative 10. So 53 plus a negative 10 will get us 43. Hence why we have angle XYZ 43 degrees, or XYT is 43 degrees, and I'll type that in. This is tough because it's combining a lot of things that we've been talking about in the past with parallel lines cut by a transversal, that there's 180 degrees inside of a triangle, and our mid-segment theorem that we just practiced recently. So there's a lot going on here. Let's try one more together. Hopefully my numbers are nice and pretty in this problem, which they are. There's no negative numbers. So let's try this one more time, and we're going to do it a little bit quicker. XZ we know is half of RT, so 78 divided by 2, that gets us 39. So XZ is, that's 39 degrees. Oh, sorry, not 39 degrees, it's just a length of 39. Pardon me. So that's 39, X to Z. ST, well, ST is right here on the right hand side, that's double of XY. So 61 times 2 gets you 122. So the length from all the way from S to T is 122. So ST is 122. Now angle RYX, that's this angle down here. To find that angle, we have to know parallel lines cut by a transversal. We have to know that XZ is parallel to RT by definition of mid-segment theorem, because they're told that these are all mid-segments, even though it doesn't look like it. We know that XY can be represented as a transversal. So by definition of alternate interior angles, if we extend this and make this a little bit longer, we see that this angle here 106 and this red angle that we're trying to find is also 106. So angle RYX is 106. Now we got to find angle XSZ. XSZ, that's that angle up all the way on the top. So I'm going to leave those parallel lines in. We'll get rid of this angle that we just found. We also know that there's 180 degrees inside of a triangle. So 180 minus 106 minus 72, that leftover has to be 2 degrees. So that little angle right there is 2 degrees. Now, we got to do a little parallel lines cut by transversal again. We could take these two lines, YZ and RS. We could extend those parallel lines. You could use this blue line as a transversal. This 2, by definition of corresponding angles, this angle here and this angle there, S Z whatever is also 2 degrees. And then by alternate interior angles, from the black line being the transversal, that 2 in this guy is also 2 degrees. So angle XSZ is 2 degrees. Now we have XYT. XYT. Well, we know this guy's 2 degrees. We know that RYX is 106 degrees. I'll type that in there so you could see it. So 106 degrees from here to here. 2 degrees from here to there. We have to know how many more degrees until we get to 180 degrees, because on one side of a line there's 180 degrees. So we do 180 minus 106 minus 2. So 180 minus 108, it gets you 72 degrees. So this angle here, ZYT, ZYT is 72 degrees. Now we're asking for XYT, so XYT involves both the 2 degrees and the 72 degrees, so 2 plus 72 gets us a total of 74. So the angle from XYT, that entire red angle, is 2 degrees plus 72 degrees, which gets you 74 degrees for angle XYT. Alrighty, that's all the time I got for today. Hopefully that's enough information for this more challenging material of putting multiple puzzle pieces together or multiple concepts together to solve a bigger and greater problem. All right, I know this is challenging. That's why this will be like an extra credit problem on the test or quiz. If you have any questions, feel free to give me an email, send me an email that is, or come to Extra Help. All right, have yourself a good night.